Here we have a composition of an arcsine function inside a cosine function. We're going to want to first determine what is the arcsine or inverse sine of negative 2/5, and then take the output of that and do a cosine function on it. I'm going to show two methods for doing this. First method would be just using technology, just using a calculator. It doesn't really matter in this case if we're in degree mode or radian mode. What we can do here is take a sine inverse of negative 2/5 and see what that gives us. Now keep in mind I'm in radian mode. And so this right here, it doesn't look like one of the common angles. Like it's not pi over 2, it's not pi over 3. I don't really recognize that number. But then what we'll do is we'll do a cosine of that answer. It looks unclear if it's a rational number or irrational number. But let's keep in mind that the output of an arcsine is going to be an angle. And then the output of a cosine of an angle would be a decimal between 0 and 1. Now, is that number rational? We could find out by using the math button. Hit enter for choice 1 to convert it to a fraction. So apparently it's not rational, because if it was rational, the calculator would have converted it to a fraction. So it's irrational. Now, angles, if we're working with radians, could have pi in them. That's really common. But this is not an angle here. This is the output of a cosine of an angle. So more likely, its irrationality is due to it being some kind of square root of something. So we could try squaring it. And after we square it, we find that the result is a terminating decimal, which is rational. So that's going to be really common with these. If you can just square the result of your cosine of the angle, then you may get something that is rational. We could convert this to a fraction now using the math button. It's 21 over 25. Remember, though, that we have squared our answer. So 21 over 25 isn't our final answer, but our final answer is actually the square root of 21 over 25. That brings us back to the number that we needed. So that's the answer. We can simplify it by applying the radical to both top and bottom separately. And it won't simplify any more than that. So that's one method for getting answers to these using just technology alone. Now, if we want to do this by hand, then we should draw a triangle that's relevant to the situation. So keep in mind that the entire argument of the cosine here is an angle. Okay, you can only do cosine on an angle. So this is the angle, I'll call it theta. Theta is the arcsine or sine inverse of -2/5. So what does that mean? It means that the sine of theta here is -2/5. Now, we have this acronym for sine and cosine and tan, which says SOHCAHTOA, where the sine of the angle is defined as the opposite side over a hypotenuse. And the other ones are the cosine of the angle is going to be the adjacent over the hypotenuse. And the tangent of the angle is the opposite over adjacent. But we want to use this one here. So this definition of sine tells us that our opposite side needs to be -2. And 5 is the hypotenuse. So let's draw a triangle that has those dimensions. All right, so let's say that this is the -2. I'll call it the opposite leg. And so that would make this the angle theta. And then the hypotenuse is 5. So with this information, we could actually solve for the missing adjacent leg using Pythagorean theorem. So let's use Pythagorean theorem here. So I'll call this adjacent leg A, and the opposite leg could be B. If we do A squared plus B squared, that'll equal the hypotenuse C squared. So we'll plug in our lengths here. The negative is only really relevant to the sine calculation. We just need to know the size of the leg. So we find that A, the missing leg, is the square root of 21. Now that we know that, let's go back to what we're being asked to find here. We're asked to find the cosine of an expression, which is really an angle, theta. And so this angle theta is the thing that we're trying to find the cosine for. So when they ask us to find the cosine of the sine inverse of -2/5, they're asking us to find the cosine of this angle theta, which I've drawn, because this angle is the sine inverse of -2/5. So if we want to know the cosine of it, we should use the SOHCAHTOA concept that the cosine of the angle is defined as the adjacent side over the hypotenuse. So our adjacent side here is going to be the radical 21, and the hypotenuse is 5. And therefore, we're going to get the final answer of radical 21 over 5. which matches what the calculator had said.